Hi guys, welcome to this another videos of this lecture series. So this is Dr. Murthy working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is the lecture series of automotive engines and emission control. And then in this video we are going to discuss about the impact of air fuel ratio on emission and the other factor. So the air fuel ratio is very important in any SI engine where the air and fuel is mixed in the proper ratio, and then it is applied or it is fed into the combustion chamber during combustion process in the combustion chamber. So the in this previous lecture videos we have discussed about the air fuel ratios, and then stoichiometric air fuel ratio, and then lean air fuel, and then classification like a lean air fuel ratio, rich air fuel ratio, and then also we have variable air fuel ratio in modern engines. And then here we are going to discuss about the impact of the air fuel ratio in about the emissions. So first we start with the lean mixture, that is a lean air fuel mixture, and how it going to affect or how it going to give the performance and then emission factor. So when it comes to performance, the in the lean mixture we are having the higher quantity of the air and with the lesser quantity of fuel. So we have the stoichiometric ratio of 14.7 is to 1, where the 14.7 is the quantity of air, and then 1 is 1, that is the part of the fuel is in the air fuel ratio. When with the lean air fuel mixture, it is the air fuel ratio is more than 14.7 is to 1, where the 14.7 is the more quantity of air is present in the air fuel ratio. And with similarly simultaneous with the lesser part of fuel is presented in the air fuel ratio. With the lean air fuel ratio we have the higher quantity of air with the lesser quantity of fuel, means we get the complete combustion process, and then the when during combustion process the entire quantity of fuel is get the enough oxygen from the air, so that it give the it gives complete burning of fuel, and then it gives the complete combustion, and then it increase the fuel overall fuel efficiency of the engine. So with the lean mixture, while lean mixture reduces carbon monoxide and then hydrocarbon with the complete combustion, so we get a lower or reduced CO emission, and also with reduced hydrocarbon emission, so they can increase NOx emission due to the higher combustion temperature. So with the higher quantity of oxygen inside the combustion chamber, and then it is more enough to burn the fuel. So with the excessive burning of fuel taking place inside the combustion chamber, so likewise increase the overall temperature inside the combustion chamber, so it leads to increased NOx emission. So as we know that the NOx emission is mainly due to the extreme temperature rise in the combustion chamber during combustion process. So this lean air fuel mixture will reduce the CO emission, reduce the HC emission, likewise, and it increase the NOx emission. And then with the rich air fuel mixture, we have the values of air fuel ratio lesser than 14.7 is to 1, where the 14 lesser quantity of air, that is lesser than the 14.7, and then with the lesser quantity of air, and then with increase the part of fuel in the mixture, so that we get with that the higher quantity of fuel is present in the air fuel ratio, so that we get higher amount of power, where it require higher load application we can go for rich air fuel mixture, so that we get the higher quantity of the fuel inside the combustion chamber. So rich mixtures leads to higher carbon monoxide hydrocarbon emission, where the higher quantity of fuel is present, at the same time we get the lower quantity of the air, means we get insufficient oxygen. So it is insufficient oxygen, it is not enough to completely burn the fuel, so that we get unburned hydrocarbon and then carbon monoxide emission, and then contributes to soot and particulate formation due to incomplete combustion because of insufficient oxygen. Then the environmental and regulatory consideration, with emission standards, the environmental regulation often requires engines to operate near the stoichiometric air-fuel ratio to ensure that the catalytic converter effectively reduce the emission. And then with the engine calibration, the manufacturers calibrates engines to meet both performance and the emission requirements, often balancing between lean and air fuel mixture, lean and rich mixtures as needed. So with the environmental emission standards, as it is suggested that to maintain the stoichiometric air fuel ratio, that is 14.7 is to 1, so that it can maintain the emission standards, and then we can get the as much as possible with the stoichiometric ratio. Next, the challenges with maintaining optimum air fuel ratio, altitude and temperature, and then variation. As we already discussed, the air fuel ratio is varying, depends on the condition, the environmental condition, the fuel quality, and then the engine what kind type of engine we are going to use. So these are the factors will affect the air fuel ratio. So it is the real headache for us to maintain the optimum air fuel ratio. With altitude and temperature, the changes in altitude and ambient temperature can affect air density and necessitating adjusting in air fuel ratio. Next, with the fuel quality, the variation in fuel quality and then composition can also impact the ideal air fuel ratio, requiring the engine's management system to adapt accordingly. Thank you.